In this lesson, we're going to look at the IS architecture and software. Basically, we're going to talk about some of the basic processes, and in fact, you should be familiar with those basic processes that are associated with operating systems. What other things do we have? We're going to look at how they handle interrupt handling. Of course, if you think of CPUs, if it's crunching along on a program and you move the mouse, it has to redraw the screen to track that mouse, so it has to interrupt whatever it was doing and deal with the mouse and those types of things. The other thing we expect software to do is have a way of creating and destroying processes. And that makes sense to me, right? If a process starts because, maybe you want to print this document out, and so it starts a process for spooling that print job and putting it into a format that the driver can use. And when it's done, we don't want to keep using process power resources, right? Resources are memory and processing speed use on the CPU. We don't want that to continue to run. When it's done, we want it to go away. Also, process state switching. Again, there may be multiple processes, and one of the things with the multitasking and multi-threading is the ability to be able to switch between these different processes to give each of them their own amount of time. Process synchronization, inter-process communication could be very well, the ability of with the results of one process talking to the, another process. Input-output processes like the mouse I mentioned. We also expect these software programs to be able to do management of memory. Like with Windows, we have virtual memory, so that we can, emulate having more actual physical memory than we really do to be able to handle the needs of the applications that are running. Now, as we are looking at the software, and especially if we want to kind of focus this discussion on operating systems, because that's a great example of software, we need to make sure, though, with regular software, that we check it for compatibility as to whether or not it's going to work on whichever operating system that we use. Some of the things we want to look at, of course, is there access control software. That means whether it's the operating system or some other software. Let's say you got an accounting package of software. Do I want anybody that can walk up there and just launch that program and see all of the financials about the company, payroll, and those types of things? Probably not. We want to know that they have to log in. Data communication software, database management software. In fact, we've talked about DBMS, right? That's a separate program that runs and stores data in the side as tables and the rest of that. Program library management systems. You might have tape and disk management systems. Network management software, dealing with network communications, job scheduling software, a variety of utility programs, usually for monitoring or maintaining or testing how things are working, like your software or other applications. Now, the most important software that's probably related to the computer is the one I just mentioned, the operating system. And it's the operating system that really is the interface between us, the user, the applications that we're running, and the hardware. Now, the operating systems vary in how they manage those resources and how comprehensive that management is going to be. For example, if I have a small workstation, I really only need my operating system to really help me in the cataloging of files, loading programs, maybe some network communication. I certainly don't need an entire directory service running on there for something like Active Directory or those types of things. A mainframe has to have an operating system that's capable of handling a large volume of transactions to be able to work with an extensive amount of resources. If I have a server that has multiple users connecting to it, it needs to be able to facilitate multiprocessing and multitasking as well as multi-threading. Now, the integrity of the operating system is an important requirement and utilizes specific hardware and software to do things such as protecting itself from deliberate or inadvertent modification. In fact, that's kind of been one of those little evils that we've seen with Microsoft. And it's, by the way, not that there's something wrong with Microsoft, but it was something wrong with us. For years, for over a decade, Microsoft kept telling us, don't log in as an administrator, or even on your home PC. Log in as a regular user. Because that way, if you download something bad from email, or if you go and download something bad from the internet, and it runs and installs and infects your machine, it can do it because it's using your account as an administrator. So we were told, log in as a user, so that stuff can't get installed. And so then, out comes Windows Vista, Windows 7, and we get these little pop-ups that say, do you want to do this? Do you want to do this? And people are getting annoyed. And it was like, well, what else do we do? I have to protect myself from a deliberate or inadvertent modification. And since you weren't doing it, the operating system added that in there. We also want to protect privileged programs from interference with other user programs. In fact, I would think I want all my programs to be free of interference from all the other programs I'm running. You should be able to provide process isolation. That means multiple processes should be able to run concurrently, knowing that they will not interfere with each other. So if I'm clicking on print for a document, and I've got another process that's drawing a screen of a spreadsheet, I don't suddenly want the print to go to the spreadsheet, that type of thing. I want them to stay isolated from each other. And they should enforce least privilege. That means the process should only be allowed those permissions that it needs to be able to perform the functions. For your system and data integrity, it's important that you correctly and consistently define, enforce, and monitor the operating system environment, as well as keeping track of granting permissions. This is a responsibility of your IS management. Software patches are another important part of maintaining the integrity of an operating system. Those patches are to fix bugs that we know of, to fix vulnerabilities, to add new features, lots of things that we need to see about those software updates. Your computer activity can be logged for analysis of your system functions. Some examples of an activity log would be data file versions that are used for production, logging program access to sensitive data, what programs are scheduled and running, the utilities or service aids that are being used, the operating system operations, your database monitoring, even auditing of access control. And if you notice, all of this is really, we're saying audit, 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 and most of it is automated, that you should be able to turn on with as easy as a few clicks on a couple of different screens. And our goal, of course, is in auditing is sometimes for looking at performance, looking at resources being used to understand capacity planning. We can also use it to look at security issues. And all of this is important information that you would want to be able to have recorded. And like I said, it can help you as long as you don't wait till it's post-mortem, after something bad's happened. Then go look at the black box and see what's up. This is one of those things that you can, if you can't review it yourself or have a team review it, there are a lot of programs out there that can analyze logs and start to show you signs of warning. Your data communication software is what we use to transmit messages or data from one point to another. Now, that transmission might just stay inside that actual box. I might be communicating information from Microsoft Word to Microsoft Excel. In fact, do that a lot, right? Click and drag, drop things over. It could be remote communication. I could be sending a file to a file server or retrieving one. Now, your simple data communications have three components, and they're pretty straightforward. You have the source or the transmitter. You have the path that the transmission is going to go on, and the receiver. If it's an internal communication, yeah, there's still a transmission path. That was back to that inter-process communication we were talking about. If it's across the network, then I have a wired, wireless path that I'm going to take through switches, through routers, and through all this other equipment. Now, your data management capabilities are going to be enabled by the system software components, and they're designed to support the definition, the storage, sharing, and processing of user data, and to support file management. Now, data management, we're talking about actual tables of information, right? And so they are managed by some sort of system software. And they have components. We're going to look at some of those components that they would use. And those components can help support, as I said, the definition, what an object is. If I say I have a table, well, what does that mean? What is a table? All right, so we have a definition. And, of course, storing it, making it available for others. And that's an important aspect of what I expect from my software when it comes to data management. On the file organization, your user system data is usually organized into manageable units. Now, what those manageable units are kind of depends on the actual file server. But what we do know is that as we're looking at the data, I shouldn't say file server, but the data management system, it could be that the way it handles the data is in a sequential manner. meaning it looks at one record being processed after another, going from beginning to end of the file. It could also be direct random access. That means that the records are addressed individually based on a key and not related to the data itself. So now you're saying, well, what does that mean? Well, let's imagine you have a database server, and I want to look up all the customers in California. Well, I don't need to go to the top of the list and go one by one through that list. I can look at a key, the key in this case, California, and I can go right to those records and grab that information immediately. That'd be more of your direct random access. Sequentially might be in the processing of a file, a Word document, or processing of a spreadsheet or a program that you've written, where I'm going to look at each record that's there one after the other.